Hello, welcome back to our calculus series where we learn calculus without knowing calculus. So what are we going to do in this chapter? We're going to learn one of the most misunderstood question in calculus, and that is, what does dx actually mean? It's all about movement. Now we're going to understand what this movement really means and what this movement causes. The algebra trap. So in your algebraic mind, when you see two variables sitting next to each other, for example, in this case, like we are seeing two examples, x, y, your brain may think it is x multiplied by y. We have a, b sitting next to each other. You may say a multiplied by b. That is not true in calculus. So in calculus, when you see dx, does it really mean d multiplied by x? The answer is no. So what does this really dx means? Let's look at this. We have in front of us, we have x and y axis. So x is what our value is. So initially, this value is on this axis 0, 0. We're gonna make a movement in the x-axis or in this direction, let's say by dx, or this dx for let's say this dx is 3. So we moved by 3 units in x direction. So if we moved in the x direction, we're going to have the result. Let's say that the y value moves by dy. What does that mean for us? That means our position has moved from 0, 0 to this location on our Cartesian system. Now we make another movement in the x direction by the same amount, same dx. So we move in this direction again by 3 units. That means if we go by the same rule, we move in the y direction also by, let's say, 3 units. So let's look at what happens to our system. Now we have a new position. So you can draw a line through this. So this is what dx means, that for a movement that we do in x direction, there is a change in the y direction also. So for every dx change, we have a movement along y. This is what the cause and effect is, that for a cause or a action that should take place, there is a effect which produces y. So if you look at this picture in front of you, we have a system function. We call it an equation also, or the rules of the system. When x goes in, it produces y. Now we change the x by a small amount dx. It changes y by dy. So what we have in front of us, that we have x plus dx cos y plus dy. So we choose the movement in x. That is our independent variable. When we change the independent variable, the system determines what is going to be movement in y. That is our dependent variable. So it's all about cause and effect. Dx is about movement. So how small should dx be? Is there one value that can be used for every system? The answer is no. There is no one perfect value. So how do we decide what dx is? It depends on the context. Let's look at a few examples. Let's take the first example where we are dealing with a system where we're going to be measuring currency, let's say in $1 million. In this case, if we choose a movement of dx is 50 cents, that is pretty small as compared to $1 million. Now let's take another system where we are dealing with, let's say, a system that is only $10. In this case, a movement of 50 cents is significant. Let's look at another example. Measuring distance. Let's say we are measuring distance because of a movement between one planet to the next. If we are measuring distances between planets, if we say that there's a movement of 1 meter, that is pretty small. But if we are measuring distance between two cities, in this case a dx of 1 meter, that can be significant now. So this movement dx, it depends on the context of the system, what we are trying to capture. So what is the right movement? How do I decide it? So let's look at an example. Let's take an example. We looked at our x and y Cartesian system, a system that is a steady growth. So we make a movement of, let's say, dx here. Then we made another movement of dx there. In this case, since the system is a steady growth, a movement of dx, even if it's big, it still captures the system correctly, because you can take the average between two movement points and that gives you your y. That is your effect that has happened. Now let's look at another system. Let's look at our, let's say, exponential growth system. Now here we are at x. If we take a big step dx here, we really do not capture the actual system itself, because between this big movement that has taken between x and dx, the system has taken a shape which is a curve. We cannot take average now, because an average between this x dx is not going to represent our system correctly. So what is the conclusion of this? So a right movement, which may be big and is correct in one system, but the same big movement in the other system will not represent the correct system. So there are multiple examples that you can use. For example, here we have taken our exponential growth. You can take a logarithmic growth. Same thing will happen if we make a big movement. If we take a big dx, we are not going to capture the correct behavior of the system. So the right movement depends on the type of system you are trying to understand, the type of system you are trying to capture. So that is the essence of this lecture, of this lesson, where x represents your current value, your current position. Dx is the movement that takes place in your value. And that movement, dx, causes a change in our result. And that is what the calculus is about. Calculus is studying the movement. Calculus is studying the cause and effect of this movement. I hope I was able to explain what is the meaning of dx. We have answered the most misunderstood question in calculus, what dx is. I hope you liked it. Subscribe, like our channel, and I'll see you in our next lesson. Till then, take care. Goodbye.